It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about infinite limits and its theorem. So let's try to visualize our infinite limits. So when we say infinite limits, we will be viewing that one as, or we will be obtaining a vertical asymptote in there, wherein if you try to look at this particular graph, we've noticed that we have here an x values approaching to a particular value, which is a 0 here. And notice the behavior of our graph. Once we move closer to 0, our graph here moves down dip towards the negative infinity or the negative values of your y. So our limit here is the negative infinity. Oops, sorry on that one. That's negative infinity. And then if you try to look at this graph here, notice that once we move closer to our value, which is x, we are going to also be moving upwards towards our positive direction of y. So once we are going to check on our limit here, our limit of our function is approaching also towards a positive infinity, because this will be moving up towards negative, the positive values of your y. So that is a positive infinity. So that is how we view our infinite limits in a graph. So let's now talk about the different theorems. So here we have here, will let our r be a positive integer if r is even, meaning to say if this r here is number or is a number between 2, 4, 6, 8, 10, 12, and so on, even numbers, then we will have limit of our 1 over x to the power of r as your x approaches a 0, that will be equal to a positive infinity. Because if you try to look at the limit of, let's say for example, the limit of 1 over our x being raised to a particular value, let's say 2, as your x approaches a 0, if we are going to substitute our x value here as 0, this will become a 1 over 0 squared. This is equal to 1 over a 0. So that will become an undefined. Now, whenever you've got an undefined value here, when it comes to limit, there are 3 possibilities here. One is when you've got a positive infinity as your limit. The other one is a negative infinity as your limit. And the last one is adini, meaning it does not exist. Now, how to know whether this does not exist or whether that is a positive infinity or a negative infinity? We will be basing that one here on our different theorems. So let's say we've got 1 over x squared, and we must find our limit on that one as our x approaches to 0. Then we are going to determine first the limit of our 1 over x squared as your x approaches 0 coming from the left side, because remember the topic wherein we are going to find a limit, and then we have to make sure that the left hand limit and the right hand limit are the same. So we will be doing that one also here. So we will be checking whether what will be our limit coming from the left side of 0 and right side of 0. So let's start with this one. Now for this one, once we have here a limit of 1 over x squared, as your x approaches as 0 coming from the left side, this will become a 1 over, we know that 0 squared will lead to 1 over 0 squared will lead to an undefined thing. So that is why instead of replacing an x here with a 0, we are going to get values of your x coming from the left side of 0, but very close to our 0. So you can start with, if you try to look at our number line, the number line here, this is our position for the 0. On the left side, we've got a negative 1. So most likely the point here, which is close to 0, could be our negative 0.001. 0, 0, 1. So we may try that one. So we have here negative 0.001, and then we square that one. This will lead to a 1 over. Once you square that one, that will become a positive. Negative 0.001 squared, that will be equivalent to 0.000001, which is positive. Now, this would mean if you try to divide that one, the one with 0.000001, that will be equal to a 1 million. 1 million is a very big one. And if you try to add more zeros to that one, to the values, let's say you've got negative 0.0001, this one here will become bigger and bigger. And notice that this is positive. So, meaning to say it will be becoming bigger and bigger and bigger, but that is a positive. So, it's moving towards a positive direction. And your limit here will be equivalent to positive infinity. So when you say limit of 1 over x squared, as your x approaches a 0 coming from the left side, that is equal to a positive infinity because you've got a bigger value in there. Now, next one, what we are going to do now is to check whether once you've got a positive here above 0, or meaning to say once we've got the limit of 1 over x squared, as your x approaches 0 coming from the right side, whether we will still be getting the same value. So we will try to find that out. Let me just erase this. So let's try to find that out by simply trying out what we did a while ago. But this time, we are going to get numbers from the right side of our 0. Because again, we've got the left side, which is a positive infinity. So we'll try to check whether the right side is still a positive infinity. So we have 1 over x squared. So again, we are going to get the limit of that one. This time we will be getting a value coming from the right side of 0. So if this is 0 on the number line coming from the right side, we've got 1 here. Once we pick this point here, which is very close to our 0, this is equivalent to a 0.001 as well. So we've got here 1 over 0.001 squared. That will be equal to 1 over 0.000001, or that is equal to a 1 million still. So again, that is going to be once you change or add more zeros here, then that will also be becoming a bigger value. So that means to say we've got a limit of 1 over x squared. As your x approaches 0 coming from the right side, that is positive infinity. Since we have the same value here from the left hand rule and the right hand rule. So automatic, our limit for this particular expression, the limit of 1 over x squared, as your x approaches to 0, that is positive infinity. So that is how we get our limit for that particular value. Once we've got there a undefined expression, we can try to test out our left hand and right hand limit, whether they have the same value. And again, the only cases there for a number over a 0 there or undefined value is going to be 3 cases. It could be either a positive infinity, a negative infinity, or a DNE. DNE, if their left hand and right hand are not the same. Positive infinity, if they have both left hand and right hand limit as positive infinity. Negative for if they have both negative infinity on the left and right. But let's go back to the theorem. And the theorem says if r is even, if you try to look at this 2 here is even number. So if you got there r is even, by the way, r is our exponent. So once your exponent is even in this format wherein you've got 1 over x, and then you've got an exponent there, if r is even, automatically once your x approaches to 0, if you try to look at that, we are now viewing on that particular entire picture. So meaning to say we're checking on the left and right hand limit as whether they are the same. For every r which is even, everybody, well, you've got their similar limit from the left and right hand, which is a positive infinity. So what I'm trying to say here is, regardless of whether you've got there a positive or negative, as long as you've got your r as even there, automatically we've got only one answer for that one, and that's a positive infinity. Same goes with this one. If you try to look at this is 1 over r root of x. So if your r there is even, regardless of whatever it is, whether you've got only a 0 in there or a negative in there, automatic you'll get a positive infinity. Try to move on to the second one. So if r is odd meaning to say you've got the numbers 1, 3, 5, 7, 9, and so on. So if that will be your exponent on x, then you will have two cases here. You can have a negative infinity, you can have a positive infinity as well. So, or it could be also a DNE later on, because what we're trying to have here only is the left hand limit and the right hand limit only here. Now, going back to the theorem, so once you've got r is odd, once you have the limit of 1 over x to the power of r, as your x approaches 0 coming from the left side, you'll get a negative infinity for that. And then once you've got there a limit of 1 over r root of x, as your x approaches 0 coming from the left side, that is a negative infinity as well. Now, once you've got there a limit of 1 over x to the power of r, as your x approaches 0 coming from the right side, of course, that is a positive. And then, of course, for the limit of 1 over r root of x, as your x approaches 0 coming from the right side, then, of course, that is a positive infinity. So let's try to have an example. An example here is once you've got there a limit of 1 over x to the power of 5 as your x approaches 0 coming from the left side. So once you've got that, automatically we can just simply try to get an example why it's becoming a negative infinity because of this pattern here. So let's say, for example, I'm going to choose on my x value as, if you try to look at our number line, this is 0. From the left side of that, we've got negative 1. I'll be picking on negative 0.01. So I'll have that one. If I'm going to replace that here, 1 over negative 0.01 raised to the power of 5, notice once you've got an odd exponent, automatically that will become also a negative. So if you try to have the 0.01 being raised to our power, which is 5, you will be getting so you will be getting 1 over negative 0.12345. So I'm counting now the number of zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I mean, yeah, 9. Okay, so that's it. So that will be the particular value. So once we try to divide this one, of course, that will give off a negative value. That's gonna be negative 10 billion. Okay, so let me just write that one. So that will be the value. So if you try to add more zeros to that one, that will become bigger and bigger. There will be more zeros to it here. So automatically we're just going to foresee that 1 as 1 over x to the power of 5. We get the limit of that as our x approaches 0 coming from the left side. That will be a negative infinity. So if you try to test out those theorems, if you want to find out whether that is really true, you can test out by simply getting values and then trying to replace that one there, and you will eventually see that most of the numbers are bigger and becoming bigger as you move closer to that particular value, which is a 0, either coming from the left side or right side. Okay, now let's try to go to an example here. We've got a limit of 1 over x to the power of 7 as x approaches 0 coming from the right side. So instead of us getting a value coming from the right side of 0 and plugging that one in and then trying to do every algebraic computation in there, that would take time. So we will be using the theorem, the shortcut of that one, and simply looking at the exponent of our x, whether it's even or odd. So for this one, we've got odd because that's 7. And then we've got, for the odd, we have possibilities. It could be either positive or negative, but if you try to look at this is coming from the right side, and then this is an odd one. So automatically, this is a positive infinity. Okay, next we've got the next one. We have one limit of 1 over x to the power of 16 as your x approaches 0 coming from the right side. This is even. So that means to say if that is even, we'll have all as positive. So this one is a positive infinity. Next, we have here a limit of 1 over x to the power of 11. As your x approaches 0 coming from the left side, this is odd. So that means this is a negative infinity because that is coming from the left side. Next, we have here limit of 1 over x to the power of 4 as your x approaches 0 coming from the left side. This is even. So that means to say that this is a positive infinity. Because again, if your r is even, regardless of whatever is this, whether it's coming from the left side or right side, that will be approaching to a positive infinity. Next, we have the limit of 1 over 5th root of x as your x approaches 0 coming from the right side. So this is now odd, and this is a coming from the right side. So automatically, this is a positive infinity. Next one, we've got limit of 1 over 8th root of x as your x approaches 0 coming from the left side. This is even, and this is with or coming from the left side. Automatic, this will be now a positive infinity. And then we have here the last one, limit of 1 over x as your x approaches to 0. We cannot directly go that this will be our positive infinity, negative infinity without testing out our left and right hand rule. But even though that's the case, we've seen the theorem in there a while ago. But then again, this is odd. So we do not have a theorem on that one under the odd r because our r here is 1. So that's odd. Now, let's try to test out our x approaches to 0 coming from the left side first. So once we try to get value here, we can have our x as 0.1. So we have 1 over 0.1. You can actually get more values to it where that is closer so that you can really from the left side. So that should be a negative. So we have to divide 1 by negative 0.1. That will be a 10. Negative 10. Okay. Once you try to increase that one, once you try to add more zeros to it, let's say, for example, I'm going to have here the limit of 1 over x. But it's really up to you if you want to go directly to having that one with more zeros under that. You can go directly for that one. So 0.01. I'm adding now zeros on that. So 1 divided by negative 0.01, that will be equal to 100. Negative 100. So that will be now becoming bigger and bigger. Now you can add more zeros in between 0 and 1 here, and that will becoming a bigger and bigger one. So we have here a limit of 1 over x as your x approaches 0 coming from the left side. That's a negative infinity. And then we try to check on our limit of 1 over x as your x approaches 0 coming from the right side. So this is now equal to, we try to get values of x from the right side of 0. So we can have here 0.1. So we've got 1 over 0.1. That will be equal to a 10. And then if we try to add more zeros between 1 here, so we can have 1 over 0.01, and that will be equal to 100. So notice as you add more zeros in between 0 and 1 here, your value also becoming bigger and bigger and becoming positive. So our limit of 1 over x as your x approaches 0 coming from the right side, that is a positive infinity. We've got limit on the left-hand rule, and then the right-hand rule are not the same. We have negative infinity and positive infinity. So the limit here of 1 over x as your x approaches 0 is a DNE. So that is how you get your limits for those particular examples. So I hope that you learned something. So I'll add more videos on it with the infinite limits. So please stay tuned for more videos. Kindly like, share, and subscribe. I'll see you on my next video.